Hello and welcome to PMCD MATHS Teaching. This video is going to be covering sketching quadratic graphs to include roots, axes, intercepts and turning points. Particularly hopefully this will be useful if you've never taught this before, it's the first time, but if you have taught it before you might find something useful in here as well. Okay, the rationale behind the way that I've approached this. Okay, so I think we can see there, it's our cell on it. If we don't value it, they're definitely not going to value it. And, you know, we know if you're preparing these students, it's usually on the higher scheme for GCSE, we're leading those students up to getting to A-level. We want to really, ideally, to come out A-level thinking, right, I've got algebra, my algebraic methods, and I can see what that's looking like graphically where possible. I mean, obviously some functions are a little bit hard to see, but quadratics, yes, we should definitely be able to visualize that. That should be popping up in one part of their brain. They should be seeing that at the same time as they're solving something algebraically. As I said, it's up to us really to sell this. So one of the things I do is I'll have it in my first 5 questions I'll have at the start of each lesson. To start off with, I'll drop this in quite regularly and then periodically over a period of time. So they feel good at it. You know, they feel like they're good at it. And, you know, students say they don't want to do something or they're not good at it or they don't like it, usually means they don't feel they're good at it. And if they're not good at it, they can get better if they practice. And I think we've got to teach them that as well. The things we feel good about are the things we feel we're happy to do. And we can practice to get there. Okay, so a sequence of teaching, things that should have been covered, solving quadratic equation by factorising. I haven't put it in there. Obviously, expanding brackets as well would be, you know, they would have done that beforehand, I expect. Plotting quadratic graphs, positive and negative coefficients of x squared, because they need to recognise that in the sketch, so they'll know the shape of that curve. And then we're on to what we're doing today, which is the sketching of quadratic graphs. Okay, so start with the properties, maybe going through a bit of the language. Okay, turning point, maximum, minimum, root, and intercepts would be important as well there. So we can talk about those. Turning point, I think it's a good idea not just to say, you know, with maths, it's always to explain why you can call it a turning point. I mean, there's a lot of words used in maths, and even the word quadratic, you know, quad obviously mean 4, but it's just, you know, 4-sided shape's a square, so we're talking about squared terms there. But it's important for the students, it just causes noise in their thinking if it's there, words are there and they don't understand or can't make sense of what it means. So turning points, 2 ways of thinking about this really, I suppose. What's happening is the points, the y coordinates here, if we look at this graph here of y equals x squared plus 5x plus 6, I would explain that as the y coordinates are decreasing, and then after this point here they start to increase. So after this sort of the bottom of this graph here, as it changes, okay, it changes from decreasing to increasing in value. So that's why we've called it a turning point. You know, if you want to link to A-level and you've done a bit of gradient work, you could say the gradient, if you want to draw some tangents in, you could say it's where the tangent changes from a negative to a positive gradient, or as in this case, a positive gradient to a negative gradient. Okay, but at least that gives some meaning to the word turning point. So we're actually, you know, that'll hopefully help them realise that the point we're after are these points here. And if we ask them to say which is the maximum minimum, I think logic for them would be quite obvious that this is a maximum on this one and this one's a minimum on the left-hand graph there. And you know, if you want to go further, you can talk about local maximum, local minima. You know, this is maybe any part of the graph. For a quadratic, it isn't obviously, but it just depends how far you want to go with that. But at least getting those words in there is important. So quite an analytical way of going about sketching these. What I would do here, so I want to talk about 1 here, okay? So obviously we've got x squared plus 2x minus 15. The coefficient of x squared is positive, okay? The shape, therefore, we know is going to be a U shape. Roots where y equals 0, so we've got 0 is equal to x squared plus 2x minus 15. Okay, what do we get? 0 is equal to x plus 5, x minus 3, given us solutions x equals -5 and x equals 3. Okay. The y-intercept when x equals 0, the easiest one, I think. We're going to get y is equal to -15. And I usually put the coordinates in here with these actually. So I'd say, okay, that gives me -5, 0, and 3, 0. This would give me 0, -15. And the coordinate of the turning points, label it max and minimum. Now, what I normally do is get them to sketch this at this point and then go from there. So, sketching it. Now, you see in the rationale, I said some people, they get squared paper, they want to sketch it perfectly on squared paper. So, what I do to sort of overcome this, to get them away from this structure and this, you know, they do feel a bit scared sometimes moving away from squared paper. What I do is I'll ask them to provide sketches on mini whiteboards that haven't got squares on them. And also that gives me an opportunity to assess how well what information they've got on their boards. So something I might, you know, so what I would do then is might say, okay, well, we've got the shape. I'm going to give you 1 mark for that. I'm going to give you 1 mark for each of these roots. Okay, the solutions. You would have talked about that when you were solving factorizing quadratics and solving quadratics by factorization. 1 for the y-intercept and 1 for the turning point. Okay, if I was going to give marks for this. So what I'll do when they show them in their mini whiteboards, I will say, okay, you've got 3 marks, 4 marks, and I'll tell them, you know, there's 5 marks available here. Okay, so we'll come back to the turning point in a minute. Okay, sketching the graph. Okay, so what have we got? We've got -5. So as I say, it's not accurate, but you can get some of the proportions slightly right, as good as you can possibly get here. Minus -5 and 3, so the 3 is close to the y-axis than the -5 is. And the y-intercept is -15. Now, I don't know how I'm going to do this with this sort of mouse controller, but we'll have a go. And then they sketch the graph. Now, this is where we get a little bit of a problem here, because this is quite a common thing to see here. They'll sketch the graph, come down, and they'll turn there and come back up. Okay, so an automatic assumption sometimes as a misconception is that this axis intercept here is the turning point. Now, a little bit of discussion you can have there. I mean, you can bring them into this. If you've got a couple of people that have got, you know, they've got different graphs, you can use them to compare and decide who's more accurate. But we know, because of the symmetry of the quadratic, the turning point has to be, if we've got a horizontal x-axis, the turning point has to be exactly along the x-axis, has to be halfway between the 2 roots. The x value does. So the x value here, and how do we find halfway between roots? So this is another thing. You add those numbers up together and divide by 2. So -5 plus 3 is -2 divided by 2. We're going to get a turning point -1. Okay, so if I'm drawing this now, if I'm drawing this graph, come down to 15, but I need to keep going down a bit further before turning up. Okay, so there's my graph. So actually at the moment, how many marks have I got? I've got 1 for the shape, 2 for the roots, that's 3, 1 for the y-intercept, and I need to get this turning point now in the right place. Okay, now this last mark is going to encapsulate the fact that this turning point doesn't happen at the y-axis. So we want this point here. What do we know about that point? Well, they should know it's -1 something. And again, you know, it's the wraparound, isn't it, of understanding these quadratics. How are they going to find the y coordinate? Well, most recently they plotted graphs for quadratics, so hopefully they're going to know, oh, I substitute that -1 into my original equation. So y is going to be -1 squared plus 2 times -1, subtract 15. So I've got y is equal to, what's that, 1 minus 2 minus 15, which gives me -16, I think. Does that fit? Does that make sense? Yes, it does. And there's your graph completed. Okay, now I'm not trying to teach you, I'm just trying to show you the things that we can pick up as we're going through this. Well, I think there's an element of skill here, you know, in understanding about this turning point. And from now on, all graphs that I'm sketching or getting them to sketch with quadratics, we're going to put that turning point in there if we can. Okay, and I say if we can, it all depends on these roots. Sometimes you know, if these are completing the square and you get irrational roots, obviously the average and then the substitution becomes a bit unwieldy. But you know, if you can't get the turning point, you should show the turning point in the right position. Okay, so in this case, it's not at 50, it's not on the y-axis, it's further over. Okay, so having done a bit of exposition myself, this is where I like to get them involved, using the mini whiteboards, and off they go. Okay, now they can do the work in their book as well if they like, and provide the sketch on the mini whiteboard. As long as they've got it in the book as well, I don't mind. It really doesn't matter. But these can be assessed yourselves. Now look, just another little point here. These last two examples I've chosen purposely, example 2 and example 3. Okay, if you look, we've got x squared minus 7x plus 12 and minus x squared plus 7x minus 12. Now the reason I've done this, maybe you can think, one's got a positive coefficient, the other's got a negative coefficient of x squared. And the reason is that they both have the same roots. Now, again, this can cause fuss. How can two different graphs have the same roots? And again, it's another discussion point, isn't it? Okay, I think, what have we got here? What have we got? The roots in this are, let's do it on this one, it'll be easier, I think. X, and again, you know, if you're throwing up rough axes as well, this is going to encourage them to do the same. Okay, do not let them use the squares on the paper. Get them used to being able to create these sketches. So what we got? X negative minus 3x minus 4. So that's going to be a 3 and a 4, isn't it? I think. Are my roots. Okay, so for this one, we end up with something like this, with a 12 there. And for the other one, where we've got y equals minus x squared plus 7x minus 12. What I do to encourage them to make this easier, some of them try and factorize with a negative x in the bracket. What I sort of encourage them to do is take the negative 1 outside and write it as x squared minus 7x plus 12. Okay, so when they factorize this, you've got 0 is equal to minus, and you're going to get x minus 3, x minus 4. Makes life a lot easier. And then they can see also, oh yeah, of course it's the same. It's the same, isn't it? We've got the same factors, except this is negative. So this graph, it's got the same factors, but the shape is an N shape. So it's going to look like this. And that, not very well drawn there, would be obviously crossing at negative 12 there. That little connection, you know, that can be easily lost. Okay, so then it's, if you've emphasized all that, I think then they're ready to start practicing, and you know, you can do a bit more on the whiteboards if you want. I give these ones, you know, we do these one at a time. Normally I uncover those. Independent learning from there onwards, depending on what we've got. And I've got some negative coefficients of x squareds in here. And that would give me confidence that they're where I want them to be. Okay, so this will link on and be useful when we come on to completing the square, because I like, from now on, every time I get solutions, I like them to sketch what the solution would look like. So they become more and more confident. And you know, I say to them, your brain is, you think of it as split in two. One side of it is algebra, your mathematical brain. The other side is graphical. And, you know, you should be switching between those to try and solve problems as and when. You shouldn't just be working in one mode all the time. But that's me, anyway. Okay, I hope that's been useful, and I will see you next time.